Hey everyone, right here on the table I have a portable air conditioner that's designed to run off 48 volts directly. This is the CYBERTAKE S2 Pro. Quickly break down some of the specifications for the S2 Pro, starting with the cooling power. This is rated at 5100 BTUs cooling. It's also rated at 6100 BTUs heating because this also functions as a heat pump. As for the weight, it comes in at about 25 pounds or 11.6 kilograms, and it's rated to pull up to 550 watts or less depending on what mode you have it set to. If we flip the air conditioner around, on the back you'll see the input port. This is an XT90 port, and I love that this is not proprietary. You can connect any 48 volt source up to this port. You still have the ability to run this off wall power. For example, they do include this power supply in the box. You can see the output is 48 volts at 11.5 amps or right around 550 watts. How much power do we actually save by running this off DC power? Because the other option would be to connect it to the power station inverter and use that power supply box, but that's essentially going from DC power to AC power, then AC power back to DC power. So there's a lot of conversion losses in there. I'm also curious about the actual runtime you'd get if you're running this on max mode with a power station. So let's do some more testing. So in my first test, I'm going to use this inline watt meter to measure the power consumption of the included power adapter, while this is set to max heating mode because that pulls the most power. So after about 5 minutes of running the max heating mode, we are seeing about 545 watts of power consumption using the included power adapter. So this gives us a good baseline of what power numbers to expect running off AC power. So now let's test this on DC power to see if it's any more efficient. So all we have to do is wire it up to the DC breaker and then it should power everything on. Now this watt cycle adapter cable originally came with ring terminals, but I've cut those off and I've crimped on these ferrules, and then it's just the same process. So positive on one side, negative on the other, and then all we have to do is tighten down those screws. It's good to go. So with everything wired up, all we have to do is flip on the DC breaker. It powered up. So now I have the EcoFlow Delta 3 Plus powering up the S2 Pro. It is on max heating mode, so I'm going to let this run for a few minutes, and then we'll check out my clamp meter and my voltmeter. So after running the load for about 5 minutes, we are at 9.92 amps and 51.08 volts, which gives us about 506 watts. So a saving of about 40 watts running this on DC only. Now 40 watts may not seem like much, but after 5 hours, that's 200 watt hours, meaning that you could run this on eco mode for an additional hour just because you're running this off DC power. Now that is only considering the efficiency losses of this adapter. We still have to calculate the DC to AC conversion of the power station. Now each one of those is going to be a little bit different depending on the size of the inverter, but I will say it's typically around 12 to 15% additional losses going from the DC battery to the AC inverter. So just also calculate that in. So it's definitely going to be more efficient running off DC power only. Now I'm hoping you guys learned something new after watching this video. For example, running a 48 volt load like this portable AC is really easy off power station expansion battery ports, and the modifications are fairly simple. I'll include the parts that I used down in the video description. Now a portable AC like this, being non-proprietary, is a pretty big deal. It basically allows you to power it off multiple sources, and I think that this one here offers a really good value because it's cheaper than the competition, but it still performs really well. I think this would be excellent for overlanding, car camping, in your RV or trailer. You know, I used it in my house, and you could also use it in a couple different outdoor scenarios.